Hello students. So in the previous video, we had seen the criteria for similarity of triangles and we had solved the first problem of the exercise. Let's continue with the problems. And one important thing is we are not going to follow the like the order in the textbook. We'll follow a different order so that it will be very easy for the exams. So let's solve the second question first. Then we'll be solving different questions in a different order. So first, let's solve the second question. So in the second question, they have given us a figure in which triangle ODC is similar to triangle OBA. It is already given that the triangle OBC is similar to triangle OBA. Angle BOC is given as 125 and angle CDO is 70 degree. Find angle DOC, DCO and OAB. So let's solve this problem. Okay, students, let's look at the solution. So they have given triangle ODC is similar to triangle OBA. The first thing that we have to look here is, see, whenever two triangles are similar, it means they have got same shape. Same shape in the sense they have got same angles. Now, whenever we write two triangles are similar, we write in such a way that the corresponding angles are equal, meaning the first letter O will be equal to the first letter O will be equal to O, meaning angle O will be equal to angle O. We always write it in this fashion, and D will be equal to B and C will be equal to A. Okay, this is how we write, meaning this angle C here, this angle C will be equal to A and this angle B will be equal to this D. Okay, so what will B become? The D is 70 degree, so B will also become 70 degree. Therefore, angle OBA will become 70 degrees. I repeat it again. If two triangles are similar, then corresponding angles are equal. And we write it in such a way that the first letter of the triangle, that is O here, that will be equal to O. And similarly, the middle one, D will be equal to the middle one, B here. And C will be equal to A, meaning the angle O will be equal to angle O. Angle D will be equal to angle B. Angle C will be equal to angle A. So angle D here over in this triangle ODC, D is 70 degree. Therefore, B will also become 70 degree. Now, let's find the remaining angles. Now, if you observe angle DOC, that is this angle DOC and the adjacent angle 125, they are on the straight line, isn't it? So therefore, if you add them, you should get 180. So that's what we have written here. Angle DOC plus COB is 180 degrees. So what is the reason? LP, linear pair. So we know the value of COB, which is 125 given in the question. So let's substitute that. So we want DOC. We don't want this 125. Let's transpose it. So if plus 25 goes outside, it will become minus 125. So 180 minus 125 gives us 55. So DOC is 55 degrees. So this angle here is 55 degrees, this angle. If this angle is 55, the below one will also be 55 because they are vertically opposite angles. So that's what we have written. DOC is equal to AOB because they are vertically opposite angles. And now we are going to use angle sum property for the triangle DOC or triangle ODC. What is angle sum property? If we add three angles of the triangle, we should get 70. So D here is 70. Here it is 50. And how much? 55, sorry. So DOC is 55. So 70 plus 55 is 125. So here we get how much? 180 minus 55. Sorry, 180 minus 125 gives us 55. Okay, that is 180 degree minus 125 degree. That gives us 55 degrees. Okay, so that's how we got OAB as 55 degree and DCO is 55 degrees. So by this we have found all the required angles. Let's get into the next problem. As I told you students that we are not going to follow the textbook order. So we had solved second question, but we are going to solve fifth question now. We'll solve third question later. Okay. The fifth question is S and T are points on sides PR and QR of a triangle PQR. So we have got a triangle PQR in which S and T are points on it. and it is given that angle P is equal to angle RTS, and we have to show that angle RPQ is similar to, sorry, the triangle RPQ is similar to triangle RTS. So let's do that. Okay, we have taken the figure here, triangle PQS, PQR, in which S is a point on the side PR, you can see in the figure, and T is a point on the side QR, and it is given that angle RTS, so that is this angle, is equal to angle PQR. So we have to prove that triangle RPQ is similar to triangle RTS. Now remember, whenever it is given in this fashion, that you have to prove one triangle is similar to another triangle, the hint is given here itself. Okay, definitely if two triangles are similar, we know that the corresponding angles are equal. That is, angle R will be equal to R, and angle P will be equal to T, and angle Q will be equal to S. Okay, it is very definite that this is the pattern, but we have to just try to find the reason why these are equal. Okay, that is all we have to find. If triangle RPQ is similar to triangle RTS, if that is what we have to prove, it is very clear that angle R will be equal to R, the first alphabet with the first, second with the second, the third with the third. We have to just find reasons for it. Now, if you observe in the triangle RPQ and RTS, angle R, the first alphabet, angle R is equal to angle R. Why is that? Because it is common angle. If you observe here, in the smaller triangle and the bigger triangle, this angle R is common, right? Whether you take RTS or you take the PQR triangle, angle R is common. And the next one, P is equal to T. The middle alphabet P and the middle alphabet in the other triangle T are equal. Why are they equal? Because it is given in the question itself that angle T, that is RTS, this angle RTS, this one, is given equal to this one. So T is equal to P because it is given in the question. So it is just, we have to show that two angles are equal. If two angles are equal, then the triangle become similar using AA criteria. So this is the pattern that we are going to follow in the next few problems. That is, in the question itself, they'll give us to prove that two triangles are similar. By then we get the first alphabet is equal to first, second is equal to second, third is equal to third. We have to just give reasons for them. We have to just find reasons why they are equal. If that is done, the problem is done. So let's start with the next question, students. Next question that we are going to take is the seventh one. In the figure, that is this figure, which is below 6.38, altitudes AD and CE of a triangle ABC intersect each other at point P. We have to show that there are four sub-questions. We'll take the first one. Triangle AEP is similar to triangle CDP. That's what we have to prove. So as I told you, if you want to prove two triangles are similar, it is very easy that we have to prove it by AA criteria. And all the problems which we are going to take now, the first few problems are based on AA criteria itself. We have to try to find the reason the first alphabet A and the first alphabet C are equal. That is, angle A will be equal to angle C, E will be equal to D, and P will be equal to P. We have to just find the reasons for them. So let's do that. So I have taken the figure. So we have to prove that triangle APE, that is this triangle, AP is this triangle, which you have got now, this triangle, and CDP is this triangle. Okay. So let me write triangle number 1 and triangle number 2. Okay. So in this triangle, we have to find, we have to prove these two triangles are similar. So as I told you, the first alphabet A will be equal to C. Angle A will be equal to C. Angle E will be equal to D. And angle P will be equal to P. We have to just find the reason. And do not do this mistake. This triangle has also got P in it, and this triangle has also got P in it. Therefore, P is common angle. That is not possible, okay, all the time. The P that they have mentioned might be a different one. We have to look into the figure, then we have to conclude. So triangle 1 and triangle 2. If you observe here, angle P in triangle APE and triangle CDP, angle P are equal because they are simply vertically opposite. And if you observe here, the angle E is 90 degree, angle D is also 90 degree. But the first alphabet, angle A is this one. So this one. So this is angle A and this is angle C. So we don't know why they are equal. Okay, so let's not worry about it. Let's take the other two. Angle P is equal to angle P, vertically opposite. Angle D is equal to angle E, vertically opposite. Sorry, 90 degrees. Right. Therefore, if two angles are equal, we can say that they are similar using AA criteria. Going to the second sub question. In the second sub question, we have to prove that triangle ABD is this triangle, the bigger one, ABD, okay, this triangle, and the other one is triangle CBE. Okay, we have to prove these two triangles are similar. It's very easy. If you observe, this angle B is common in both the triangles, therefore angle B is equal to angle B. Let me write it down. We have to prove in the second sub question. We have to prove in the second sub question that triangle ABD is similar to triangle CBE. As I told you, the first alphabet will be equal to the first, and the second will be equal to the second, and the third will be equal to third. Okay, we have to just find the reasons for them. This is very easy. Angle D and angle E. D and E are equal because both are 90 degrees. What is D over here? 90 degrees. And what is E over here? 90 degrees. So angle D is equal to angle E, 90 degrees. One is done. One more angle. The middle alphabet, B is equal to B. Why B is equal to B? Because this belongs to both the triangles. Okay. So it is a common angle. Therefore, the two triangles are similar using AA criteria. Similarly, if we follow the same pattern for the next two sub questions, we can easily solve this. Let's get into the next question. Okay, students, in the next, that is, we're going to solve eighth one. E is a point on the side AD produced of a parallelogram ABCD, and BE intersects CD at F. We have to show that triangle ABE is similar to triangle CFP. So we have already drawn the figure. If you observe, ABCD is a parallelogram. So what is a parallelogram? Opposite sides are parallel, isn't it? So AB will be parallel to BC and AD will be parallel to BC. Now what we have to do is we have to prove that the triangle ABE is similar to triangle CFP. Before that, AD is extended, AD is produced, and it is met at point E. Okay, it is extended and it is met at point E. From point E, we are intersecting, we are joining with B so that it intersects at F. So we have got two triangles here, bigger triangle ABE and a smaller triangle BFC. We have to prove that these two triangles are similar. Okay, so the triangle ABE, if we want to prove triangle ABE is similar to triangle CFB, it is very clear. Angle A, the first alphabet, A will be equal to C, B will be equal to F, and E will be equal to B. Okay, it is very clear. We have to just give reason. So if you observe, this is a parallelogram, right? So AB will be parallel to CD and BC will be parallel to AD. The opposite sides are parallel in a parallelogram, isn't it? Now, if you observe this angle, angle A and angle C here are opposite angles of a parallelogram, isn't it? So the opposite angles of a parallelogram are equal. So the first alphabet here is A and the first alphabet here is C. Why A is equal to C? Because angle A is equal to C because they are opposite angles of a parallelogram. Opposite angles of a parallelogram are equal. In a similar fashion, remember, whenever two triangles, whenever two lines are parallel, we should always go with this alternate angles. How do we find alternate angles? Using Z shape, isn't it? So this angle and the angle here, that is, if you observe, we are getting a Z shape here. Let me draw it and show you a Z shape. Okay. Therefore, this angle and this angle, that is angle ABF or ABE, is equal to BFC using alternate angles. So whenever two lines are parallel, we should always go with alternate angles. Now we have shown that two angles are equal. Therefore, the triangles are similar using AA criteria. So let's get into the next question. So next we're going to start with 11th one. In the figure, E is a point on the side CB produced of an isosceles triangle ABC. AB equals AC if AD is perpendicular to BC and AF is perpendicular to EC, we have to prove that triangle ABD is similar to triangle ECF. So that is what we have to prove. Okay. So we've already taken the figure. So let's first see which is the triangle ABD. Let me shade it in a different color. So triangle ABD is this that I'm shading. Okay. This is triangle ABD. We have to prove this triangle ABD is similar to triangle ECF. Let's take ECF triangle, the one which I'm shading now. So we have to prove these two triangles are similar. Okay. Now, as I told you very clearly, if you want to prove two triangles are similar, okay, here we have to prove the two triangles are similar. Okay. Now we know that A will be equal to E, B will be equal to C, and D will be equal to F. We have to just give reasons for that. So if you observe very clearly, angle D and angle F are 90 degrees from the figure. If you observe here, angle F is 90 degrees. Similarly, angle D is 90 degree. So we can use that reason. D is equal to F because both are 90 degree. And since it is given as an isosceles triangle, AB equals AC, if two sides are equal, then their opposite angles are also equal. Okay, so AB equals AC. So the opposite angle of AB is C, opposite angle of AC is B. Therefore, B equals C. So the reason for the middle alphabet B equals C is because it's an isosceles triangle. Therefore, we have proved two angles are equal. Therefore, the triangles are similar. So let's get into the next question. Okay, students, let's take the third question. In the third question, diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at point O. So we have to prove that OA by OB is equal to, OA by OC is equal to OB by OD. Okay. So let's draw the figure. So I have drawn the figure already. ABCD is a trapezium. What is meant by a trapezium? It is a quadrilateral in which only one pair of opposite sides are parallel. As you can see here, only AB is parallel to CD. The other two sides, AD and BC, are not parallel. If you extend them, they'll meet somewhere. Okay. Now, remember, if you want to prove such a ratio are equal, if you want to prove this ratio is equal, simple step, we have to take two triangles and prove that they are similar. Now, which two triangles should we take? Basically, inside this trapezium, there are many triangles, isn't it? So which triangle should we take? For that, we'll observe this, what we have to prove. Now we have to prove OA by OC is equal to OB by OD, isn't it? So observe the numerator. In the numerator, we have got OA and OB. So which triangle has both OA and OB in it? It is triangle AOB, isn't it? So this is the triangle. It has got both OA and OB in it. Similarly, observe the denominator. It is OC and OD. So which is the triangle that has got OC and OD in it? It is triangle DOC. So if I prove these shaded triangles as similar, then we can easily prove the given thing. So how do we prove it is similar? Very simple. Angle O, if you observe here, this angle O and the below one, angle O, are equal because vertically opposite angle. And if, as I told you in the previous question, if a line is parallel to one line, if two lines are parallel, you should always go with alternate angles. If you observe this angle here and this angle D here are forming a Z shape, you can see the Z shape here. Let me retrace it. So you're getting a Z shape over here. I'm just tracing on it. Therefore, if two lines are parallel, alternate angles. So this angle name is OBA or ABO, which is equal to ODC, alternate angles. So we have proved two angles are equal. Therefore, the triangles are similar using AA criteria. If two triangles are similar, as I told you in the previous video, if any one condition is satisfied, the other two. That is, if two triangles are similar, then I can tell The corresponding angles are equal and corresponding sides are in proportion. Therefore, if two triangles are similar, we can say corresponding sides are in proportion. How do we take this corresponding sides? Very simple. Take the first two alphabets, AO, AO, CO. So AO by CO. The next two alphabets, OB, OD. So OB by OD, the first and the last, AB and CD. AB by CD. This is how we take the corresponding sides in proportion. In that, this only the first two is required for us. The last one is not required. So let's take only those two. So that is how we have proved it. Okay. So we want OA, but AO, OA both are one and the same. Okay. So one thing in this problem, whenever we want to prove such a ratio, that is, if we want to prove that ratios are equal, like this, OA by OC is equal to OB by OD, we have to take two triangles and prove that the triangles are similar. How do we get two triangles? Observe the numerator, you get one triangle, and observe the denominator, you get another triangle. Take those two triangles, prove that they're similar. If you prove that they're similar, we will get the required answer. Okay. So we'll continue in the next video, students. Thank you.